Part 2, this is for questions 7 to 11. Question 7 is coming from coordinate geometry, and particularly it is coming from circles. A circle with the center 5, 2 passes through the point 7, 5. Find the equation of the circle. Now, of course, we have our circle here. The center is 5, 2. The center is 5, 2. Remember, to find the equation of the circle, you need the radius and then the center. Then this point is 7, 5, so 7 is to the right of the 5, and then 5 is above 2, so maybe it's around here. That's another point, 7, 5. So I need to find the radius here. So radius, this is length of a line segment. We need the change in x, so it will be 7 minus 5, then squared, and then plus the change in y. We have a 5 and then the 2. That will be 5 minus 2, then squared. Of course, 7 minus 5, that will be a 2, 2 squared, that will be a 4. And then 5 minus 2, that's a 3, 3 squared is a 9. So meaning this one is going to be root of 30, no, not 30, it is 13. So we shall have x minus, our center is, the x coordinate is 5, then the y coordinate is a 2, and then this one will be equal to root of 13. But remember, we have to put this one on squared, and then that means that our answer is going to be x minus 5 squared, then plus y minus 2 squared, which is equal to 13. So this is our answer. Then the line y is equal to 5x minus 10 intersects the circle at A and B. Find the exact length of the chord AB. So we need to find first the coordinates of A and B. Okay, so solving these two simultaneously, we shall have, remember this is the equation of the circle. Okay, then we have the equation of the line. So where there is y, I'm going to put this 5x minus what? 10. So we are going to have x minus 5 and squared, then plus this will be 5x minus 10, but there is also a minus 2 here, squared, then we equate this to 13. We open the brackets and then we form a quadratic equation in x, which we solve to get the two x coordinates, and then we can use them to find the y coordinates. In there, we would have gotten the coordinates of A and B, and then we can go ahead and then find the exact length of the chord AB. So this is x minus 5 again, squared, plus, I need to first simplify this one. So this is 5x, then minus, this will be 12 squared, which is equal to 13. Square the x, you will get x squared, and then after that, get the 2 times x times 5, that will be negative 10 of x, and then square the 5, you get a 25. Then square the 5x, this one will be 25 x squared, then 2 times 5, that will be 10 also, then times 12, shall get negative 120 of x, and then we square the minus 12, we get 144. I can bring this on this side, it will become a minus, so that I get a quadratic. Okay, x squared plus 25x squared, that one will give us 26x squared. Then minus 10 minus 120, that one will give us minus 130 of x. And then 25 plus 144, that would be 169, not so. Then minus 13, 69 minus 13, don't you get 56? Yeah, so we shall get 156, which is equal to 0. So this is a quadratic equation in x, but can we divide all through to simplify it? Okay, we divide all through by 26. So we shall have x squared. What is 130 divided by 26 and then 156? 130 divided by 26, that's a 5. Then 156 divided by 26, that's a 6. So we have x squared minus 5x, then plus 6, which is equal to 0. Two numbers, when I multiply them, they give me 6, but when I add them, they give me -5. That will be -2 and -3. So I will write x minus 2 here, and then x minus 3, which is equal to 0. So meaning when I equate this one to 0, then x can be equal to 2. And then when I equate this one to 0, x will be equal to 3. And then from there, for each of these two values, what are the y values? So I can substitute in this one here, can have y then is equal to 5 times 2, which is a 10, minus a 10, this one will be a 0. And then how about here? We shall have y, which is equal to 5 times 3, which is a 15, minus 10, then this one will give us a 5. So this one implies that we shall have our a as 2, 0, then our b as 3, 5. Now the length of AB is going to be the square root. Change in x, we shall have 2 minus 3, then squared, then plus 0 minus the 5, 0 minus the 5 squared. So what does this one give us? We have -1 squared, that one will be a 1. -5 squared, that one will be 25. So 1 plus 25, it will be square root of 26. And this becomes our answer. Remember, they said exact length, and this one is not a perfect square, so we just leave it there as root of 26. Question 8, part A, express this one in this format. This is completed square format. There are two ways we can do this one here. I can do completing squares directly. Okay. Let me split this one into 2. We have, I can expand brackets and then equate coefficients. Okay. But let me first deal with completing squares right away. So plus the 12x, then plus 2. Now we have something like this, x plus b squared. If you are opening the brackets here, you can have x squared. Then let me actually use, let's say, the minus x minus b, whether I use plus or minus, whatever. Then this one is going to be x squared minus 2bx, then plus b squared. But I need a side to have only the x. Okay, so take this one this side. We shall have x minus b, then squared minus this b squared. This one will be equal to x squared minus 2bx. Okay, now I want you to look at what is here. The b here, then the b here. But here we are seeing the 2b. So this coefficient of x, which is -2b, right from here, it was divided by 2, not so, to give you the negative word, b. Then that -b was put inside here, then it was also squared and then put here. But remember, of course, when you get the negative and then you square, it becomes a positive. But this one here, remember, it went to this other side, and it was a positive, so it became a minus. So here we are always having a minus. Okay, so that is that. We are having something like that. So this simply implies that, first of all, we need to make the coefficient of x squared 1. So here it is not 1. So what are we going to do? We shall factorize out this -3. So when we factorize out the -3, then we shall have x squared. Then this 12 divided by -3, you will get a -4. You see that? I'm going to leave out the 2. I only need these two terms that I've gotten the what? The x. Remember, when you factorize here, you shouldn't change the meaning. This is a negative times a negative, then you get back to the positive, right? Now the coefficient of x squared is positive, okay? So what do we do next? Now we come to this one here. Just get the coefficient of x here, which is a negative 4, okay? You divide it by 2, so you get a negative 2. So we shall have x minus 2. I put it together with the x here, then I pop it out as a square. So minus, then 2 squared, like that. But then there is a plus 2. You see, this plus 2 outside here. So the completing of squares is inside here. And when I expand this one, I get this, okay? Then next, I can now open the brackets here. So we shall have negative 3 into x minus 2 squared. Then this is a negative 4 times a negative 3. That will be a positive 12, right? Then plus the 2 here. So meaning our answer is going to be negative 3 x minus 2 bracket squared, then plus 14. And this becomes our final answer, okay? So that means our, already the negative 3, you can even see it here, okay? The negative 3, you can see it here, okay? Then there is minus a, so our a is 2, because there is also minus 2 here, so a is that. And then our b is positive what? 14. So that is what we are having there. Then alternatively, you can do the expansion and then you equate coefficients. So we have this one here. Just duplicate it, put it here. Then this one is the same as you bring this one here, which is minus 3, and then x minus a squared, then plus b, okay? We continue again, duplicate this one here. So let us now expand the brackets here. We shall have x squared minus 2ax, then plus a squared, then there is a plus b here. And then next would be, you open the brackets here, multiply all through by negative 3. So we shall have negative 3x squared, then plus 6ax minus 3a squared, then plus b. Now we can equate coefficients. So the coefficient of x squared here is negative 3, and it is also here negative 3. Then we go to the coefficient of x, which is a 12 here, but then this side we have 6a. So meaning when you divide all through by 6, then your a becomes a what? A 2. This is the exact same value here, which I told you here, a is 2. Then next you go to the constant part. We have a 2 there. Then the constant here is this whole expression here, which doesn't have an x. So that is negative 3a squared, then plus b. Remember we need b. So this will be 2 plus 3a squared. Not so? But what is our a? Our a is a 2. So you square it. So 2 squared, that's a 4, times 3, that's a 12. Then plus the 2, that one will give us a what? A 14. You see that? Then we can conclude and say, I'll just bring this one here, just like that. And then where there is a, I just put a 2. And then where there is a b, I put a what? A 14. So this becomes our final answer. Then they are saying the one-to-one function f is defined by this for x less than or equal to k. Part B, state the largest possible value of the constant k. Now this one here is the same, I think it is the same as the one they gave us here, okay? And this one is an n-shaped curve because the coefficient of x squared is negative. So we are going to have an n-shaped one curve. Then we are going to have a turning point here. you just get this one equal to 0, you get the x coordinate, which will be a 2, and then the y coordinate will be that 14 outside there. Okay, so all values of y are actually less than 14. 14 is the maximum. So because it is an n-shaped curve, then it has what we call the maximum point. So they say state the largest possible value of the constant k, and they say this one is a one-to-one function. For a one-to-one function, each x value has one y value, okay? One y value, one y value. But this one, which is n-shaped, an x value here will correspond to a y value, but there is also another x coordinate here. So x1 and then x2, they will give us one y value there. You see that? So this one is not one-to-one if it is like this. But then they give us this condition here, the domain x is less than or equal to k. So we can either choose the left side of the turning point or the right side of the turning point. So for this case, they are choosing the left side of the turning point. So when we choose the left side of the turning point, that means this one becomes a one-to-one because each x coordinate will give you one y coordinate. Each x coordinate, one y coordinate. So we are just taking this part here because this one will continue like that. So it becomes one-to-one. Okay. So we see this one happening up to the turning point. Okay. So when they say that state the largest possible value of k, that is the x coordinate here, it has to be at the turning point because that is where now the curve changes either to move away from one-to-one or to be a one-to-one. Okay. So if you consider x being maybe when it belongs to all values, so you are considering the right side and then the left side of the turning point. So for that case, it is not going to be a one-to-one. So that value of k, okay, is going to be that x value of the turning point, which is a 2. So here k will be equal to 2. So what I'm saying here, you pick the x coordinate, the x coordinate of the vertex, the x coordinate of the vertex, as simple as that. Then they are saying it is now given that k is equal to -1. Still we are looking at the left, so -1 will be here, okay, but then it will correspond to a y value. Remember, this one is continuing. It will correspond to a y value. Set the range of f, and remember that the range of f, we are seeing f of x less than or equal to what? To 14, because that is if we are considering all values of what? Of x, okay? But now they are telling us to begin from where k is -1, where x is -1, because k corresponds to the x value here, right? So when x is -1, what will be the value of y? Then the rest will be less than the -1. You are going to get values of y which are less than that value you have gotten here. You see that? So what we are going to do is to get the value of y when x is -1. So we shall say for x which is equal to -1, then y shall be equal to, we can use the completed square format. We can use this one, no problem. So I can say -3, then into -1 minus 2 squared, then plus 14. So this is -3 squared, that will be a 9, not so? So 9 times -3, that will be -27. So -27, then plus 14, what do you get? You get -13, not so? So this one will give us -13. So meaning that you are having something like this. Let me actually just put it here. You have this sketch, and at this point here, where x is -1, this one corresponds to a value of y here, okay, y which is equal to -13. Our vertex here is 2, 14, okay. So this means that our range, remember range is supposed to be written in terms of the function, the domain is written in terms of the independent variable. For example, for this case, it is x. So here the range is going to be f of x, then less than or equal to negative what? 13. It is no longer this 14. It is that if the x value is this 2 here, but we are using negative what? 1 from negative 1 and then this other side, okay? So that is that. This is our answer. But find an expression for the inverse. Now, for any quadratic function, you cannot find its inverse unless it is expressed in the completed square format. So our f of x is equal to negative 3 into x minus 2. So that is why in part A, they first tell us to put it in this format, because later on they are going to ask you to find the what? The inverse, okay? So that is our f of x. So the inverse here is going to be equal to y. So suppose I take this f this side, I'll have x which is equal to f of y. In other words, you interchange x and y, okay? So x is going to be equal to, where there is x, you put the what? The y. So you get negative 3 into y minus 2 squared, then plus 14. Now we make y the subject of the formula. So let me first bring it to this side so that this one becomes a positive, okay? So we shall have 3 into y minus 2 squared, then take this x this side. We shall have 14 minus what? X. And then from there, divide all through by 3. So we have y minus 2 squared, which is equal to 14 minus x, then out over 3. Then now you can take the square root, and whenever you take the square root, you have plus or minus, not so? Of 14, then minus x out of 3. Then you take this on this side, we shall have y which is equal to 2, then plus or minus the square root of 14 minus x out of 3. Now, the inverse of the function here is going to be 2. I'm going to skip space here. We need to choose a sign, okay? Because this one is a one-to-one function. A one-to-one function is the one that has the inverse. So now I want to choose from these two, plus or minus, which one is it? But here you don't need to waste time. All you need to do is to look at the domain which was given. So in the domain, we are looking at x less than k. Okay, we are looking at the left side of the turning point. So if you are looking at the left side of the turning point, that means you're going to take the minus. If you're looking at the right side of the turning point, then you take the positive, okay? So for this case, we shall take the what? The minus, as simple as that. But if you write your answer like this, with plus or minus, then it is going to be crossed, because this is not a one-to-one function. A one-to-one function is the one that has gotten the inverse, okay? So that is that. Maybe I'm going to prove for you why I'm using the minus here, okay? Suppose we are having, remember, we are considering values less than negative 1, okay? So I can choose, let's say, x is equal to negative 2, okay? So if x is equal to negative 2, then what will be f of negative 2? So substitute in here. You have negative 3, then you have negative 2 minus 2, then you square, then plus 14. What do we get here? This is negative 4 squared. Negative 4 squared will be positive 16. Positive 16 times negative 3, that is negative 48. Not so? Negative 48. Negative 48, then plus the 14. This one gives us negative 34. So we get negative 34. Now remember, you have a function here. You have a set of values here. Then f acts on those values. What you get out is f of x. Then here the function that undoes what a function has done is what we call the what? The inverse. Okay. Now this is the domain of f. The set of values you put in f, the set of input values of a function is the domain, and then the set of output values is the what? The range. So this is the range of f. But then since this one is undoing this, what we put in the function is the domain, then this one becomes the domain of the f inverse, and then what comes out here is the range of the inverse. Are we there? Now we are going to get this value. Okay, we have gotten the negative 34, then we put it in the expression for the inverse, and then we see whether we get back to the x coordinate. Okay, so f inverse of negative 34, we shall have a 2 here, then minus. In fact, let me not put the minus, let me leave it as a space, then we see whether we are using a minus or the plus. So we shall have 14 here, then minus 38, no, 34, then we divide by 3. Now 14 plus 34, we get 48, divide by 3, that is a 16, not so? Then root of 16, that one gives us a 4. Now I have a 2 here, and then a 4 here, not so? Okay, so how do I get the negative 2 here? Do I put a plus? When I put a plus, of course, I get a 6, not so? But when I put a minus, don't you think this one will give me the negative 2? And then I come back to this. So that is why here we are putting a sign which is a negative. But you don't need to do all of this, okay? You just need to look at the side of the turning point they are considering. So if the side is the left, then you take the minus. If the side is the right one, then you take the plus. As simple as that. The result of translating the graph of y is equal to f of x by negative 3, 1 is the graph of y is equal to g of x, then power e. Express g of x in the form, this one here, where p, q, and r are constants. Okay, so what do we do here? For the translation vector is negative 3, 1, okay? We have our y, which is equal to, so when I pop this one out and I put it where x is, it will change the sign, okay? So we shall have f of x plus 3, and then this one where, when I put it where y is, it will also change the sign, so I'll have minus a 1, okay? But then this one, I can take it this side, and then it becomes a plus, right? So we shall just have plus 1. You see that? Now, let me show you how this one comes about. Suppose I have a graph of y is equal to, let's say, x squared. That is the U-shaped curve there. But then I say y is equal to, so where there is x, let's say we are putting x plus, let's say 2, okay, plus 2. So do you see that when I put a plus inside here, then the graph is actually moving to the left, okay? So when you find this graph, of course, here, moving to the left, that means you will say this is a translation of negative 2, 0. Remember, on our axis, moving to the left, x is becoming negative, right? And then y is becoming what? I mean, moving to the right, x is positive. So that means if this number here is positive, then we are moving to the right, not so? Then if it is negative, then you're moving to the left. So for the y here, when you are moving to the, y is vertical. So when you move up, it is positive. You can see the numbers are positive. But then when you move down, it is what? Negative. Okay. So since we move to the left, then it is minus 2 what? 0. You see that? But inside here, it's a plus 2. So meaning when I'm popping this number out from here, it changes the sign, and then it becomes minus. You see that? Then if let's say we put a -1 here, so it is moving down, you see, it is moving down. So we are having -2 and then -1. Suppose I change this one here to, let's say, a plus. Let's say we put +2. So do you see that it has moved up? So we are having now -2, then +2. Okay, but if I'm taking this to where y is, then it's like bringing this one this side, so it will be a minus. So you see, when you are putting this number where the variable is, it changes the sign. So I can have something like this. We have x then +2 squared. So pop this one out, you get the -2, and then also pop this one out, it will be a +2, like that. So that is what we are having here. Now let's go back to our question. When we go back here, this is a +3. That is why I put this one as a +3. Here it was a minus. Okay, so when it pops out and then comes in here, it is going to be a plus. Now, our f of x, remember, is I can use this one here, or I can use the expanded format. Okay, the expanded format, this g of x now is going to be equal to okay, let me first bring the f of x. So f of x is equal to we have -3x squared. Let's check again. Then plus 12x plus 2 plus 12x plus 2. So our g of x, remember, is equal to f of x plus 3, then plus 1. So wherever there is x, we are going to put what? X plus 3 here and there. Okay, so we shall have -3, then into, this one is going to be x plus 3 squared. Okay, replace this x with this, then plus 12, again x plus 3, and then there is a plus 2 here. Okay, so that is f of x plus 3, but then there is a plus 1 here. Okay, then we open now the brackets. So you have -3, then inside here you have x squared plus 2 times x times 3. That one will give us what? 6x. Then square the 3, that one will give us a 9. Then open here, that will be a 12x, then plus a 36, then plus, of course, this one will be 3. And then open here, that will be -3x squared, then minus 18 of x, then minus 27, then plus 12x, then plus 39. So this simply implies that our g of x is going to be equal to -3x squared, and then minus 18 plus 12, you will get a -6, not so. So this will be a -6 of x, and then -27 plus 39. Don't you have a 12 there? So we have, yes, it's a +12. So plus 12. So that is going to be our answer. So meaning our P is a -3, our Q is a -6, and then our R is a +12, and that is that. Question 9, a curve has the equation y is equal to f of x, and it is given that its derivative is this, but given that f of 1 is equal to -1/3, find f of x. So here we need to integrate. So our f of x shall be equal to the integral of the f prime. So we have 2x squared minus 7. Then this one I'm going to write it as -4, then x to the power of -2. okay, using indices. Then to integrate, remember, you take away the integral sign, okay? This is 2, then increase the power by 1, so this will be power 3, then over 3, and then minus, this will be 7x, then minus, this will be 4, then x power negative 1. When you increase this one by 1, then you divide by the new power, right? Then you have to put an arbitrary constant here because you don't know the constant that disappeared when they differentiated. And remember, whenever we differentiate a constant, we get a 0, right? Okay, so this means that our f of x is going to be equal to 2 out of 3 of x cubed, then minus 7x. Of course, a negative divided by a negative, you get a positive, right? So we shall have 4. Using rules of indices, I can take this one down, and then it will be 4 over x, then plus the c. Now, we are supposed to get this value of c by using the coordinates here. This one means here that when x is equal to 1, then f of x is equal to negative a third. And if a point lies on the curve, that means its coordinates must satisfy the equation of the curve. So we have 1 and then negative a third. So our f of x is negative a third when x is equal to 1. So you put 1 wherever there is x, okay? 7 then times 1, then 4 over 1, then plus c. So this will be negative a third, then minus 2 over 3. Like, I'm taking this one this side again. Then also this one, when it crosses, by the way, here we shall have negative 3 over 3, which is a negative 1, then plus 7. That one will give us a positive 6. Then when this one crosses, it's a minus 4. So positive 6, then minus 4. That one will give us a 2. Not so. So c is going to be equal to 2. So that simply implies that your f of x will be this, but where there is a c, then I'm going to put a 2 here, and this becomes our answer. But be find the coordinates of the stationary points of the curve. Of course, you know that for stationary points, dy dx is equal to what? To 0. So for stationary points, instead of writing dy dx, I'm going to write f prime of x, okay? That is the derived function. So it's equal to 0. Remember, our f prime of x is 2x squared. Let me check again. 2x squared minus 7x, then minus 4 over x squared. So minus 7, then minus 4 over x squared is equal to 0. So I'm going to multiply everywhere by x squared such that I eliminate the what? The denominator. So this will be 2x then to the power of 4 minus 7x squared then minus 4, which is equal to what? 0. And this one is a quadratic. This is a quadratic equation in what? In x squared, okay? So I can use the calculator to solve this, okay? I'll go to mod, then 5, that is the quadratic equation. I'll go to mod, then equation is option 5, and then quadratic is option 3. Then I'll put in 2, then negative 7, and then negative 4. Then we shall get a 4, and then negative a half. So I'll write x squared is equal to negative a half, and also x squared is equal to 4. Remember, it is a quadratic, you know, x squared, so that's why I'm writing it like this. But then in the exam, you need to show the examiner the attempt to solve the quadratic equation. You show us how you came to this. So since this is factorization, then show the examiner that you factorized. So give us the factors from which these roots come, okay? So cross multiply, that one will give us 2x squared, not so? So we have 2x squared, which is equal to negative 1. Now bring the negative 1 here, it will become a plus, not so? So we shall have a plus 1, okay? That is a factor that gives us this root. Okay, then next, bring this one this side. That one will be x squared, not so? X squared minus what? 4, which is equal to 0. So there you have cheated the examiner. You see that? But of course, this one, we remember we are supposed to take the square roots. So this one will be undefined because we don't have square roots of negatives in the real system. But instead you'll get complex roots. But we are dealing with real numbers. And then here, x will be equal to the square root of 4. Of course, when you take the square root, that will be plus or minus, not so. So your x is going to be plus or minus what? 2. Now, for each of these x coordinates, you need to get the y coordinates. So for x, which is equal to -2, what will be y, or the value of f of x? Okay, so we go back here, and now we use this one. So that means if you integrated and you got a wrong thing here, there's no way you can get the y coordinates. You see here? So that is 2 over 3 of x. So our x is -2 and it is cubed. Then there is -7x. Okay, then plus, is it a plus? Yes, 4 over x. 4 over x, then plus 2. So what do we get here? You have 2 out of 3. Then here we have -2 cubed. Of course, odd power of a negative will always be a negative. So that's a -18 there, times 2, that will be -16 over 3. Then we shall put plus 14, then -2, and then there's a plus 2. So this one gives us 26 over 3. 26 over 3. So that means here I'm going to have -2, then 26 over 3. These are the coordinates of one of the stationary points. And then also for x, which is equal to 2, what will be y? So y will be 2 over 3, then times the 2 here cubed, then -7 times 2, and then plus 4 over 2, then plus 2. What does this one give us? I'll just come back to this. Then where there is a -2, I'll put a +2. Okay, but then here we have -7 times 2, so this one will be a minus, and then this one of course will be a plus. So 4 over 2 is a +2, then plus the 2. That one will be -14 over 3. So -14 out of 3. That means the coordinates of the other stationary point will be 2 and then -14 out of 3. And that is that. Then part C, find f double prime of x. So of course this one, you are differentiating what is already differentiated. Okay, so f prime, first f prime of x, remember, was given as 2x squared minus 7, then minus 4x to the power of -2. So that means the second derivative here is going to be, drop the power and then reduce it by 1. So this will be 4x. Then of course when you differentiate a constant, it goes. Then when this one drops, -4 times -2, you'll get a +8, and then x to the power of -3. Or I can write it like this: 4x, then plus 8 out of x power 3. That is that. Okay, and then part D, they are saying hence, meaning begin from where you have stopped. Hence or otherwise, determine the nature of the stationary point. So of each of the stationary point. So we have these two what? 2 -14 over 3. -14 over 3. Now we need to put these 2 in the second derivative here. So here we shall get 4 times 2, which is 8, then plus 8 out of 2 power 3, which is 8, not so. So this is a 1, then plus the 8, that will be a 9. This 9 is greater than 0. So this simply implies that this point here is minimum. Okay, this one is minimum because if the second derivative is greater than 0, then we have a minimum point, okay? And then negative 2, the other one is what? 26 over 3. So we have the f double prime of negative 2. You just put the x coordinate, okay? So this will be 4 times negative 2, which is negative 8, and then plus 8 over negative 2 cubed. All the power of a negative is a negative. So here we have 8 over negative 8. That's a negative 1. Already here it's negative 8. So we get negative 9, right? So this will be negative 9, which is less than 0. So this simply implies that this point, negative 2, then 26 over 3 is maximum. So that is that. Then question 10 is coming from integration part A. We integrate from 1 to infinity. This one here. Okay, so this one is going to be the integral from 1 to infinity. Then I can take this one first of all up. We have 3x minus 2 to the power of negative 3 over 2 with respect to x. So when you begin the process of integration, you take away the integral sign. Then I'll put these square brackets. Now you get this 3x minus 2. Increase the power by 1. So negative 1.5. Then plus a 1, you get negative 0.5. So you'll have that negative a half. Then you divide by that new power. But then you multiply it with the derivative of what is coming from inside here. Because when it comes to differentiation, this one we are using chain rule. And for chain rule, then we multiply through. But remember, for integration, you do the reverse. So instead of, how do you undo the multiplication? You do division, right? So that is why we get this one, and then we divide it by the derivative of this one. Now it finds the power that you have put down here, so it multiplies with it, okay? So we shall have a 3 here. Now, if you forget this 3 to multiply it down here, you get a wrong thing. We don't look at anything else. So this is infinity, and then 1. And then this one is going to be, this one can somersault and then comes here. So we shall have negative 2 over 3, which I can actually leave out, okay? It's a constant, which is going to multiply with each and everything. Then here we have 1 over 3x minus 2, then to the power of a half. Because the power here is a negative, okay? So when I take it down using the rules of indices, then it becomes a positive. And then this will be infinity and then 1. Then we have negative 2 over 3 inside here. This is a very big number. So a very big number times 3, you get a very big number, right? Minus 2, you are still having a very big number. And then square root of that very big number, you still get a very big what? Number. So I will have 1 over that very big number. So the whole thing becomes infinity, right? Then minus, you are going to the lower limit. So you will have 1 over, you put a minus, right? Then put a 1 here. We shall have 3 minus 2, which becomes a 1. Then square root of 1 is a 1. So we have something like that. Or maybe let me show the substitution. 3 here, then minus 2, and then power half. Now, we know that 1 over 0 is undefined, so we always write infinity. So when we cross multiply here, we can have 1 over infinity, then is equal to 0. So 1 over a very big number, you will get 0.000000. It actually tends to the 0. So this one will be a 0. Then we shall have negative 2 over 3. Then inside here we have a 0. Then minus, of course, this one will give us a 1. So negative 2 over 3 times negative 1, what do you get? And you get positive 2 over 3. So this becomes our answer. And then next, we are given this graph here, the diagram shows the curve with this equation. The shaded region is bounded by the curve, the x-axis, and the lines x is equal to 1 and x is equal to 2. The shaded region is rotated through 360 degrees about the x-axis. Then part B, find the volume of the solid of revolution. Now, when you rotate this one about x-axis, you will again produce something like this, okay? So you see that something like this happens every now and then when you are rotating. So we have that. Now, if what we do in here, we are going to split this one down into these very many strips here, okay? And each of the strips, when you get it out, it will approximate a cylinder, okay? So if I pull out, let's say, one cylinder here, like that, this cylinder has gotten a radius. So this radius, it is from here to here. You get it? Because this part here is the same as this other part going this side, okay? Now, this one here corresponds to a y value here, okay? So, and this is the radius. So our radius is equal to y. You see that? Then when I pull out this cylinder here, okay, this cylinder like that, so I have an x coordinate here and then another x coordinate here. So in between them, that is going to be now the height of the cylinder. You see that? So that height of the cylinder here is equal to the change in the x that I'm getting from there. Now, how do we get volume of a cylinder? Volume of the cylinder is equal to the cross-sectional area, which is the area of the circle, and it is pi r squared, then times the what? The h, okay? Now, when we put all of these together, so you get for this cylinder, for the next one, for the next one, for the next one, and then you put them together, you add them all together, you integrate them into one. So to integrate is to put into one, okay? Then we are getting the volume of the whole solid that is generated from there. You see that? Okay, now we are going to have v of x, which is equal to the integral of volume of the cylinder is pi. Your r is y, okay? Y squared, and then your h is delta x. But now delta x is just the small change in the two x values here, but now we are looking at this bigger change here, okay? So that one will now turn into dx. So, and then we integrate from a certain value to another, that is from 1 to 2, okay? Now, from here, we need to get y squared. So y, first of all, is 3x minus 2, then to the power of negative 3 over 2. Now y squared will be 3x minus 2, then power negative 3 over 2, then you square this one here. So what does this one imply? We have 3x minus 2, and then you have, using rules of indices, times the 2, so this one goes right. So this one will be 3 of x minus 2, then to the power of negative 3. You see that? So meaning our volume here is going to be the integral from 1 to 2. I can put pi outside. Our y squared is 3x minus 2, then to the power of negative 3 dx. Now we begin the process of integration. Remember, you take away the integral sign, okay? Then we shall have increase the power by 1. You get 3x minus 2. When you increase this one by 1, it becomes a negative 2. Then you divide by that new power, but then times the derivative of what is coming from inside here, which is a 3. And then we shall have 2, 1 here, okay? Then we substitute and then get the answer. This is actually negative 6. Because it is a constant, I can also pull it out, okay? That means I can have something like this, maybe negative pi over 6, and then we have 1 over 3x minus 2 squared, because remember this one is minus 2. Okay, then this is 2, 1. Now what do we get when we substitute these ones here? We put in the limits. So the volume here is going to be equal to, remember we have negative pi over 6, and then we are going to put the limits. So we are going to put this 2 in here. Okay, we have 1 over 3 times 2, which is a 6. Then there is a minus 2, and then we square that. Then we go to the lower limit, 1 minus 3, of course, times 1. Then minus a 2 squared. So we have negative pi over 6. And then inside here, this is 6 minus 2. What do you get? That's a 4. Then 4 squared is 16. So 1 out of 16. And then next, we have, of course, this one is a 1, like that. So this one will give us negative pi over 6 times 16 times this one here. You get a 16. So 1 minus 16, that's negative 15. Then over that 16. So we have negative 15 over 16. And then what will be our answer here? By 3, of course, a negative and a negative, that one becomes a positive, right? Then by 3, I'm getting a 5. By 3, I'm getting a 2. So it will be 5 over 2 times 3. 2 times 16, that's a 32. So we shall have 5 out of 12 of pi. Okay? Cubic units. I will leave it there. They said find a volume. Okay? So they didn't say exact. So you can leave it exact like this, or you can put it to 3 significant figures. And by the way, this one is 32. Pardon me here. It's not a 12. 32, like that. Then next, they're saying the normal to the curve at this point crosses y-axis at point A. Find the y-coordinate of A. So we need to, of course, differentiate, because remember at the point of intersection, the curve and the line. So if I have, let's say, my curve here, okay, and then I have a tangent, that line that meets the curve at only one point, okay, I'm just assuming this is the tangent, and then this line which is perpendicular to the tangent is what we call the normal, okay, and this is the curve. The point here is 1, 1. Now the gradient on a straight line is constant between any 2 points, okay, but at the point of intersection, the curve and the tangent will have the same gradient, but gradient at every point on the curve is always different, okay. So at the point where they meet with the tangent, then they must be having the same what? Gradient. That is why the gradient function we get from the curve, when we differentiate it, it's the one that we use for the gradient of the tangent. So remember we have our y, which was given as, let's check again, this is the one here, okay. We shall have 3 x minus 2, then to the power of negative 3 over 2. So we shall need dy dx from here. You drop this power, so negative 3 over 2. Then here you have 3x minus 2. Then reduce the power by 1. So 2 times negative 1, that is negative 2, minus 3, that is negative 5, right? So we shall have negative 5 over 2. Then times, this is chain rule. Enter inside here and you differentiate this, you'll get a 3. So you multiply it all through. And then this one will give us this times that. That will be a negative 9 also. Then over 2. and then you have this 3x minus the 2. And then at this point 1, 1, what will be the dy dx, which will give us the gradient of the tangent, and then from there we can get the gradient of the normal, not so. There's a negative 5 over 2 here, so this will be negative 9 over, I can put the 2 here, then this one I can take it down because the power is a negative, so that I make it a what? A positive. So this is a 2, and then power 5 over 2. Of course, this will be 1. 1 power any number will be a 1. So we shall have negative 9 over 2. Okay, that will be the gradient of the tangent. So gradient, in other words, by the way, here I'm supposed to find the equation of the normal, and then I look at the y-intercept where it crosses the y-axis. It's as simple as that. So gradient of normal shall be equal to negative 1 over gradient of the tangent, because you know for perpendicular lines, the product of their gradients is always equal to negative what? 1, don't so? So if m1 is for the tangent, then m2 is for the normal, then to get m2 it will be negative 1 over m1. Okay, so gradient of the tangent, we got it as negative 9 over 2, and this one will be 2 over 9. So we shall have y minus, now I'm finding the equation. Okay, we are finding the equation of the normal. So using y minus y1, which is equal to m into x minus x1. Remember, we are using this point here, so we shall have y minus 1, which is equal to, our m is 2 over 9, then into x minus 1. Now on y-axis, x is 0, not so. So on y-axis, or you can make y the subject of the formula, you write it in this format, mx plus c. The c, the y-intercept, will be the y-coordinate of A, where this line crosses the what? The y-axis, as simple as that. So on y-axis, we know that x is equal to what? 0. So we shall have y minus 1, which will be equal to 2 over 9, then 0 minus what? 1. So make y the subject here, take this on this side. Of course, 0 minus 1 is a negative 1, so times this one here, you have negative 2 over 9, then you add a 1. 9 times 1, you will get 9, then minus 2, you get a 7. So meaning the y-coordinate of A will be 7 out of 9. And that is that. So this has been it for this paper. Thank you so much for watching. May God bless you. If you find the content very helpful, kindly like, share, and even subscribe. See you in the next videos.